How do we multiply and divide numbers written in scientific notation? So first of all, let's turn to division. So here we've got, let's imagine we've got 10 to the power A times 10 to the power B. So that is equivalent to saying 10 to the power of A plus B. So we add the exponents together. So if I show you an example, you'll see what I mean. So let's say we've got 10 to the power 3 times 10 to the power 2. That's 10 times 10 times 10. That's this guy. Times 10 times 10. That's this lady. And so that's like that. And so that gives us 1, 2, 3, 4, 5 altogether. 10 to the power 5, which is 10 to the power 3 plus 2. And that holds true for any example. How about if we now have a number in proper scientific notation, not just a power of 10? So we'd write that as C times 10 to the power A times D times 10 to the power B. So that's like saying C times D. So we just multiply these coefficients together, and then again we add together the exponents. That's 10 to the power A plus B. So again, let me show you an example. So if we've got 3 times 10 to the power 3 times 2 times 10 to the power 2. So here we've got the coefficients and the exponents to deal with both. But anyway, that's 3 times 10 times 10 times 10 times 2 times 10 times 10. So that's like that. Then we can regroup them together. You can multiply numbers in any order you like. So it's 3 times 2 times 10 to the power 5. 1, 2, 3, 4, 5 tens in there all together. So that's the same as, so that's 6 times 10 to the power 5. So that's 3 times 2 times 10 to the power 3 plus 2. So we're multiplying the coefficients, but we're adding the exponents. Right, so division is the same idea, quite similar. So here, let's imagine we've got 10 to the power A divided by 10 to the power B. That is equivalent to 10 to the power A minus B. So we're subtracting instead of adding, but it's the same general concept. So for example, if we said 10 to the power 3 divided by 10 to the power 2, that would be 10 times 10 times 10 over, because this fraction line is the same as a division, isn't it? 10 times 10, then we can cancel these out. So that gives us 10, which is 10 to the power 1, i.e. 10 to the power 3 minus 2. So we're subtracting the two different exponents, one from the other. And then how about if we've got C times 10 to the power A divided by D times 10 to the power B. So there we divide, again we divide these, the C and the D together, but then we subtract the two different exponents. I think that makes sense. Add some brackets all the way over here. So if we've got an example, so let's say we've got 3 times 10 to the power 3 divided by 2 times 10 to the power 2 now. So that would give us 3 times 10 times 10 times 10 over 2 times 10 times 10. Again, we can cancel these out. So that gives us 3 over 2 times 10 to the power 1, which is 3 over 2 times 10 to the power 3 minus 2. And in fact, that's equal to 1.5 times 10 or 15 if we wanted to add it, wanted to work it out fully. And how about if we have an exponential expression, like for example, let's say we've got C times 10 to the power a, and the whole thing is raised to the power b. So that is equivalent to saying, so just we distribute the b into each part of the expression, so that's c to the power b times 10 to the power a times b. Let me just show you in an example that that's true. So for example, let's say we've got 3 times 10 to the power 3 and the whole thing is squared. So that means that that's equal to 3 times 10 to the third times 3 times 10 to the third. So you're multiplying it by itself. So if we have a thing like this, it all just goes together. So 3 times 10 to the 3 times 10 to the 3, which is 9 times 10 to the 6. And so this is 3 squared, and this is 10 to the power 3 times 2. So that matches what I've set up here.